lesson is on limiting and excess reactants. We will answer the questions, what are they? How are they determined? How do we use them in stoichiometric calculations? And how do we calculate how much of the excess reactant remains when using limiting reactants? Definitions: limiting reactants limit or determine the amount of product that will be produced. The limiting reactants are the one that there's proportionally less of and that run out of first, whereas the excess reactants have a quantity which is more than enough to react with the limiting reactant. Say, for example, we have this reaction here between nitrogen and hydrogen producing ammonia. If we start with 10 grams of nitrogen and 2.50 grams of hydrogen, as the reaction proceeds, both of the quantities of these are going to decrease. Eventually, one of them is going to get to zero ahead of the other one. So if nitrogen is the limiting reactant, it will get to zero while there's still some of the hydrogen remaining. At that time, the reaction is going to stop and the amount of the ammonia will stop being produced. And so the one that runs out of first is again the limiting reactant. It's the one that there's proportionately less of and runs out of first, stopping the reaction. So limiting reactions therefore produce how much of the product is produced and also how much of the excess will be used up. An analogy could be made to, say, making a sandwich. If we make a chemical equation for a sandwich, such as 2 pieces of bread, 1 piece of cheese, 1 piece of ham equals 1 sandwich, and then we go to our kitchen and this is what we find: 6 pieces of bread, 5 pieces of cheese, 2 pieces of ham. We can only make 2 complete sandwiches because ham is the limiting reactant. We will run out of ham before we run out of the cheese or run out of the bread. And so the ham then determines how many sandwiches we can make. It is the limiting reactant. It also determines how much cheese is going to be used up. We have a 1-to-1 ham to cheese ratio, so 2 pieces of ham are going to, or 2 pieces of cheese are going to get used, leaving 3 left over. And we have a 1-to-2 ratio between the ham and the bread. And so if we have 2 pieces of ham, 4 pieces of bread are going to be used, leaving 2 left over. To find the limiting reactant, again, when you're given a quantity of each of the reactants, if you want to calculate which one of those is the limiting reactant, you have to arbitrarily choose one of the given reactants and then convert it to the given quantity of the other reactant and compare. If the result is higher than the given quantity of the other reactant, that other reactant then is the limiting reactant. If the result is lower than the given quantity of that other reactant, then the other reactant is the excess reactant, and therefore the chosen reactant is the limiting reactant. That's a lot of words. See how this works out. If I asked you to determine the limiting reactant for the reaction between 8.4 moles of aluminum and 6.8 moles of oxygen gas, which produces aluminum oxide, again, first thing you always have to do is write the balanced chemical reaction. And then I'd encourage you write down the given quantities. You have 8.4 moles of the aluminum, 6.8 moles of the oxygen. We want to find which of those is the limiting reactant. Arbitrarily choose one as your known. And really what we're doing, we're asking ourselves, if I want to use up all 8.4 moles of the aluminum, how much of the oxygen do I need? Do I need more or less than that 6.8 moles? And so this is just a mole to mole calculation. So 8.4 moles of aluminum multiplied by that 3-to-4 oxygen to aluminum ratio, and we get 6.3 moles of oxygen. So for 8.4 moles of aluminum, I need 6.3 moles of oxygen. Since I have 6.8, that is more than needed. Therefore, the oxygen is the excess and the aluminum is the limiting reactant. For sake of completion, let's say I arbitrarily just chose to go the other way around. What if I ask the question, if I have 6.8 moles of oxygen, how much aluminum do I need? Now I'm going to go from moles of oxygen to moles of aluminum. And so I take my 6.8 moles of oxygen that I start with, multiply by the 4-to-3 mole ratio, and I get 9.1 moles of aluminum. So for 6.8 moles of oxygen, I need 9.1 moles of the aluminum. Since I only have 8.4, that's not enough. Therefore, that is the limiting reactant, and oxygen is the excess reactant. Let's take a look at another one. This time we're given 12.0 grams of ethanol, and it's going to be combusted in 10 liters of oxygen. And if we want to find the limiting reactant, again, I've got two options here. I can go grams to moles to liters and see if I get a number bigger or smaller than this 10 liters. Again, I'm asking the question, if I have 12 grams of this, how many liters of this do I really need, more or less than that 10.0? I could go the opposite. I could go from 10 liters of oxygen to moles of oxygen to moles of ethanol to grams of ethanol. But let's go in the forward direction. So if I have 12 grams of ethanol and I want to find out how many liters of oxygen do I need, I convert my grams of ethanol to moles of ethanol, multiply by the mole ratio to get moles of oxygen, multiply by 22.4 to see how many liters of oxygen I need. So for 12 grams of ethanol, I need 17.5 liters of oxygen. I only have 10 liters, therefore I don't have enough oxygen to react with all 12 grams of the ethanol. Therefore, oxygen is the limiting reactant and ethanol, therefore, is the excess reactant. How does this all work out in a problem? Again, it's the limiting reactant that determines how much of the product can be produced. So if I want to find out how many grams of iron can be produced from this reaction, I have to figure out, is the 20 grams of iron 3 oxide the limiting reactant, or is the 5 grams of the lithium the limiting reactant? So I have to arbitrarily choose one, convert to the other, and so I can go from grams of iron 3 oxide to grams of lithium, or the other way around. I'm going to go from grams of iron 3 oxide to grams of lithium. So we have to go grams to moles to moles to grams. And this is what that math is going to look like. So that means for 20 grams of iron 3 oxide, I need 5.21 grams of lithium. I only have 5 grams of lithium. Therefore, there's not enough lithium to completely react with the iron 3 oxide, and therefore lithium is the limiting reactant. So if I want to find out how much of the iron can be produced, I have to start with the limiting reactant, the 5 grams of lithium. And so stoichiometric calculation, I start with my limiting reactant, and I'm going to go from grams to moles to moles to grams. And so for 5 grams of my limiting reactant, it will produce 13 grams of iron. So again, it's always the limiting reactant that determines how much of the product is going to be produced. The limiting reactant also produces how much of the excess is going to get used, and therefore how much is going to be left over. So let's look at that same calculation, but this time ask the question, how much of the excess reactant is going to be left over? If this was a standalone problem, you would not already know which one is a limiting reactant. And so if you're just given a certain quantity of each reactant, you have to find the limiting reactant. Since this is the same as the last problem, we're going to get the same calculation, 5.21 grams of lithium. So lithium is the limiting reactant. So if lithium is a limiting reactant, we're going to use it to figure out how much of the iron is going to be needed. And so we're going to take the 5 grams of lithium, convert to moles of lithium, to moles of iron 3 oxide, then to grams of iron 3 oxide. Again, we're asking for 5 grams of this. How much of this am I really going to use up? And so that is what that calculation looks like. And it turns out for 5 grams of the limiting reactant, you will use up 19 grams of the excess reactant. Since we started with 20 grams of the excess, all we need to do is subtract the 2 to calculate how many grams of the excess reactant is going to remain. And so 1 gram of the excess will remain.